OHL is one of the largest international concession and construction groups in the world. It boasts over 100 years' experience and maintains significant ongoing operations in 30 countries across 5 continents. From the outset, OHL has focused on international port projects. The Alcantara Inner Basin in the Port of Lisbon and the West Pier in the Santos Port, also in Lisbon, were the first contracts awarded to the company in 1912. The OHL Group has maintained its position as a leader in port infrastructures through its subsidiary, SATO, Sociedad Anónima Trabajos y Obras, founded in 1935. Over these 80 years, SATO has earned wide experience, which has placed it at the forefront in the construction of maritime infrastructures. Its signature innovating drive and the experience garnered in the fabrication of more than 800 concrete caissons have allowed it to develop, design, and construct the SATO Levante floating dock with the application of the latest available technology. The purpose of the floating dock is to fabricate large concrete caissons for building breakwaters and docks. Its size makes it one of the biggest in the world. The floating dock consists of a metal pontoon deck measuring 60 meters long by 43.2 meters wide, rigidly fixed to 4 towers, measuring 18 by 3.6 meters, located at the corners, which provide the dock with the necessary floatability to guarantee its stability. The pontoon has 25 ballast tanks, plus an additional 4 tanks situated at the towers that enable the safe implementation of sinking and refloating maneuvers. The ballast of the tanks is filled or ballasted by gravity. Ballasting and deballasting are controlled from the control cabin situated on top of one of the towers. Over the towers are truss structures with vertical guides to enable the raising or lowering of the suspension system, using the capstans located in the base of the towers. The suspension system is a large, rigid truss structure on which the umbrella is suspended, a horizontal framework of beams bearing the weight of the sliding formwork and the working platforms. The formwork consists of stiffened steel plates that form the horizontal section of the caisson shaft. The formwork is 1.2 meters high, with a configurable geometry adjustable to the needs of the individual project. A constant separation is maintained between the various faces of the formwork using lifting yokes, connected to the umbrella by means of steel braces. The slip form is lifted using hydraulic jacks distributed on the umbrella, supported on jack rods. The whole structure comprising the umbrella, formwork, and platforms is shifted at the same time using 2 additional jacks per tower, which assist in raising the suspension structure, with the whole operation controlled from the slip form cabin. The dock also has ancillary equipment, guaranteeing the supply of concrete, machinery to assist in assembling the formwork safely, generators to ensure independent power supply, as well as elements to facilitate the positioning of the dock in mooring maneuvers. The installation is completed with other elements designed to meet the needs for supply of materials to the dock for fabricating the caissons. The fabrication process begins with the construction of the slab of the caisson, with the placement of the formwork walls on the dock. For the first caisson, the reinforcement steel for the slab is assembled on the dock. At the same time, the reinforcement of the first phase of the shaft is mounted up to higher than the sliding formwork. For the rest of the caissons, The work is carried out on the auxiliary pontoon deck, thus shortening construction time. Once the reinforcement steel has been prepared and assembled, it is transferred to the interior of the dock. The grid is elevated on the suspension structure by means of chains, and the auxiliary pontoon is removed, after which the grid is lowered and placed on the deck. Afterwards, the concrete is added and vibrated symmetrically in order not to produce any major inclinations in the dock, with the purpose of ensuring the adherence of the concrete to the caisson shaft. A rough finish is left on the contact surface between the slab and the shaft by means of a specific treatment of the joints. Once the concrete of the base is set, the formwork is lowered and the preparation for the reinforcement of the shaft begins. Rods are supported on the slab, which will act as support for sliding the formwork using hydraulic jacks, which are activated by a control system simultaneously with the jacks in the towers to guarantee the leveling of the umbrella and the verticality of the shaft. To avoid the formation of cold joints, the shaft is cast round the clock in shifts with the various tasks of reinforcement of caisson walls, pouring concrete in different batches to guarantee uniform distribution, vibrating concrete, and cleaning of working platform and formwork panels, all being carried out simultaneously. The speed of spreading concrete depends on the speed at which the concrete hardens, the amount supplied, and the size of the installations and ancillary equipment. The SATO Levante floating dock can reach a concrete sliding speed of over 30 centimeters per hour in optimum conditions of safety and quality. During the process, the stability of the dock and caisson as a whole is controlled by means of ballasting the dock tanks and the caisson cells. Once the top elevation has been reached, the reinforcement and concrete activities are eliminated, but the slip form continues sliding until the formwork is detached from the caisson. Now the whole of the weight of the formwork is loaded onto the elevation capstans, and the jack rods are removed for maintenance and reuse. Finally, the formwork is raised to a safe height and the tanks are ballasted until reaching the launching depth, the moment when the free floating of the caisson is produced, and it can be towed to the place of preparation for later mooring. The last operation is to clean the formwork so that the construction of the next caisson can begin. The large dimensions of the SATO Levante dock make it one of the biggest in the world. Its position at the forefront of innovation allows SATO to undertake increasingly more technically challenging projects and to consolidate its leadership in the field of maritime infrastructures.